So we're going to wait about 5 minutes to get started, and then we will go ahead. Dang.
You should do it on programming instead of creative.
Programming is creative.
Oh, it is?
Yeah. Dude, Twitch ads are the worst, though.
Mm-hmm. And they like beat that ad block and U block algorithm too. So we stand over here while you present.
Okay. The Slack, it's that channel. Yeah. Hey, Ian, the meeting starts at 7. I'm welcome? Oh, thank you. All right, we're going to go ahead and get started because it's 7:05. And so we'll be covering a Linux security crash course today, kind of an overview of Linux security at large. A large majority of this material was based off of the Red Hat 7 security guide. Whether or not you appreciate Red Hat's opinions, they are kind of the de facto standards for security in enterprise, as that's mostly what you would be using is a Red Hat system. So really following the process they go through for security and adding on some stuff, possibly explaining stuff better, and demoing some of the technology so you're not just reading it online. Get in touch with us if you want to hang out or get to know us better or give feedback of any sort. You can hit us up on our email, utdcsg@gmail.com. We also have a Slack channel, #CSG and ecsutd.slack.com. If you haven't been in that Slack channel, there's various other student organizations you can get involved with. AIS has a channel. ACM has a channel. You can check them out as well. We have a website, csg.utdallas.edu. That's where all of our information is posted. The slides, the video will be posted there. Updates for the meetings will be posted there. And then finally, our mailing list. If you sign in up front, check add to the mailing list. You will be added, and we send out weekly emails with information about the events that we're running. Announcements for this week. So starting not this week, but next week will be lab hangouts. So in our lab ECSS 4.619, 4 p.m. to 5 p.m. we'll be hanging out in the lab. There will be some of the officers there. You can just come hang out if you want to work on school stuff or you want to talk about security stuff. We'll be there. And you can ask us questions, ask us what we're working on, or work on something, ask for help, pretty much whatever you want. We'll do a penetration testing session. That will be, this room is 1.202, right? Yeah, so that'll be in here, February 24th, 1 through 4 p.m. and that's going to be a workshop through the pen testing process. We spent an entire semester, last semester, talking about penetration testing, largely talking about the process and procedure and not necessarily hands-on keyboard. This session will be hands-on keyboard, getting started with penetration testing, walking through standard tools like Nmap and Metasploit and how those function. And then lastly, we are in beginning of April hosting a CTF with State Farm. And so sign up isn't available yet, but we're starting to advertise it now. March 5th through 12th is when that will be open, and you'll get more information as it progresses. First question, I thought Canonical Ubuntu was the de facto Linux distro for enterprise. Depends on who you ask. I like Rail better, but Canonical is another industry solution, I guess you would say, that some people do use. So an overview of what we're talking about. I'm going through the basic access control, authentication, authorization, and audit, and then going through some more ephemeral stuff. So configuring services securely, configuring your firewall, basic intrusion detection, and then doing compliance. And so, of course, starting with authentication. PAM. One of the neatest things about Linux that you've likely never touched. Generally, people don't interact with PAM enough or much at all because it's kind of abstracted away from you as a user. You don't really care. But it is the way that you authenticate with the Linux kernel. It's super neat. Very, very different than Windows, where all of that is kind of walled off from you. PAM is 100% configurable from you as a user. This is really cool. But it also has some downsides, of course. If someone mucks with your PAM configuration and changes some things, you can do some pretty malicious things there. But most services that want to authenticate you, whether it's your lock screen, your display manager, SSH, sudo, su, all of those back into PAM for authentication. And so it's going to be all over your system. So an example PAM config, as you can see here, you have 4 different sections: auth, account, password, and session, and they're called PAM stacks. And so for the auth stack, as you can see, we have a handful of modules that are loaded, 5 here, and they have different verbs that describe how they function. And so when I enter the system auth PAM configuration, let's say I'm trying to auth as a user, then I slowly traverse down this stack. And so you start with PAM env, and you can see this has the required directive. That means if this module fails, then the entire stack fails. Similarly with fail delay, and then you have the sufficient directive, which is very different. If you hit a sufficient directive and you pass, then it automatically kicks you out and you have logged in. You finally have requisite, which means that it'll fail, but fail immediately, not go through the entire stack. And then finally required, which once again, if you fail, you fail. And so you have the following directives like I previously showed. You have auth, which verifies a user identity. And so when you're trying to actually auth as your user, you're using the auth directive. The account directive, which allows you to, it checks to see if your account is allowed to do what you think you can do. This is generally not on the level of like sudo configuration, like checking your groups, although it can be. It's a lot of time checking the time of day against your user or checking your UID against a list of UIDs to see if you can do that task. Session, which controls steps that happen at the beginning and end of your authenticated session. And so this can be setting an authentication token, removing that token, things like that. And lastly, password, which goes around changing your passwords. So if you've used the passwd utility, is using PAM in the backend to set settings for how you're allowed to change that. And then once again, the controls. Required, if it fails, the entire stack is processed and it kicks you out. Requisite fails immediately. There is different debate on what you should be using required versus requisite, and this is largely due to the fact that an attacker could reasonably gain information about your authentication stack if you're using requisite. And so if you have a check that requires something like your UID to be a certain number, and that's a requisite, I can brute force that check because it'll kick me out sooner than other checks that are happening. Whether that's true or not, I'm not sure. I have not experienced that, but that's the argument that I have seen. Sufficient, if it succeeds with no failures in the stack, then you succeed completely. This is a neat directive that causes a lot of issues if you're writing your PAM config by hand. because you might be trying to set directives below the sufficient line, expecting the user to have to continue authentication, but sufficient kicks them out early. We had that bug over at the Honors College, actually, when we were rolling out a new login solution. And then lastly, optional, which is not a very largely used option, but if it's the only directive set, like it's the only module being used, then optional matters. Otherwise, it does not. So useful modules if you're trying to secure a system. PAM fail delay, as seen here. It sets a delay for in milliseconds. It's milliseconds or microseconds for how long the user has to wait before they're kicked out. And so if you're trying to stop brute forcing on whatever you're writing the PAM module for, then you would want to use PAM fail delay. PAM Unix actually sets the user authentication from etc password to etc shadow. And so if for some reason your configuration is going to be, your PAM configuration for your program needs to auth off that directly, you can use the PAM Unix. PAM succeed if allows you to set constraints on attributes like UID, and it basically just checks the user who's trying to, sorry about the projector. The projector's broken, which is why we don't have the screen rolled down. The PAM succeed if takes in a bunch of attributes of your user and then checks them based against configuration you provide, and then will kick you through or not. And lastly, PAM PW quality. A similar one is PAM cracklib. If you used Ubuntu 14, cracklib is standard there. It sets constraints on passwords. And so if you want passwords to have a specific complexity, like a certain number of special characters, a certain number of uppercase characters for your local users, PAM PW quality is what you would use in your password config. In the, what's the .so extension for? It's a so name. You don't actually, when you compile things like PAM fail delay and PAM Unix, you're not actually making an executable file. It's just a library that gets loaded. And so the .so extension is for loadable libraries. So the thing that's actually neat about PAM, like a lot of this configuration doesn't really seem useful because it's like the system configures it for you and you don't really care. But it can be really neat when you're trying to be malicious or checking for people being malicious. And so when you're given a user that has root access to the system, which means that they can change the PAM config, you can add a handful of things that's fairly neat. You can add a malicious module that logs users' passwords. So the PAM libraries do have prior authentication tokens available to them. So it would not be hard for me as a developer to write a PAM module that takes that and either writes it to a file or sends it somewhere remotely. Fairly neat use case, and I don't know how many of y'all have checked your PAM config recently, but I haven't, so the odds of catching that are probably fairly low. Similarly, you can add a malicious module that sets a password backdoor. And so as we talked about the sufficient directive prior, as long as that module were to pass, you would be authenticated. And so you could take any program on the system you want that backs into PAM, put a malicious PAM module into it with sufficient, and set your password for the entire program. Fairly neat. And lastly, fairly easy to DOS people with PAM. If you've ever played with PAM, odds are you've locked yourself out of the system for some reason or another. And so that's generally going to be user error instead of malicious, but it is possible. And as an example of what a malicious PAM backdoor would look like, it's PAMBD. It's a project on GitHub. Really, really neat. And so there's a handful of functions that PAM modules have to implement. But that aside, this is how it works. And so you go through, and it checks the user password against a string set my password. And if it matches your password, regardless of the user, it kicks you through successfully. And so I could drop this in someone's SSH configuration for PAM. And if they have PAM enabled in SSH, I have a backdoor password to any user that can authenticate with SSH. Super, super neat. And on to authorization, which Andrew will cover with sudo.
So if you've used a Linux system, you've most probably used sudo at some point. And basically, most people just use sudo to get to the root user or to get to using a here, I'll go to the next slide. Basically, you're going to be using sudo if you need to get security privileges, which is typically root. But if you don't know, the sudo can actually do a lot more than that. There are a lot of different commands that you can do in sudo, and you can actually use it as a logging system to check and see if someone's added a user or someone has done a sudo command. If you give access to your box to someone that has sudo privileges and you trust them, but you still want to see what they were doing on the box, you can use Sudo Replay, which is another great functionality. You can configure your sudoers in etc sudoers, and basically what that does is it just lets you determine who has access to sudo and who has access to what kind of sudo command. So a lot of you might have used, I don't know, when I first started using Linux, I used sudo su. Didn't know really what it did. I just thought it let me get into the root directory. Basically what I did, or what it does, is it switches you to a super user. Sudo su is just switching you to whatever user you extensiate. So if you type in sudo su and a username, it'll change it to the username that you type in. Another one is sudo tac I, which switches you to the user root environment. So instead of dropping you in a sudo shell in whatever environment you're in or whatever directory you're in, it basically just switches you to a shell that's independent of the one you were in previously. The sudo tac s changes you to a sudo shell in your current directory, which basically allows you to use sudo in the current directory that you're in if you need to do something temporarily. And then sudo tac I tac u allows you to check the capabilities that you have as a user and what you can do. It's really useful if you're on a box that you got user on and you need to see what kind of capabilities you can do for sudo. So another useful tool of sudo, as I said, is Sudo Replay. Basically what Sudo Replay does is it allows you to check what someone's done in the sudo, And to enable it, you just have to type in viz sudo, which types in vi and edits your sudo config, and type in these at the bottom. I believe that they are commented already by default, and you just can uncomment them. But if you don't want to find them, you can just type these at the bottom. Basically, what it's doing is it's setting the default log output. It's setting where it will output to and what it'll be checking for. And then you can use sudo replay tac l to list your sudo commands. And the tac l can be of a user or of a certain file that you want to output. You can also you can do more with this. You can also replay it in real time, which means that instead of it running based off of what you just listing all of the commands it did, you can see how long they took and what the time intervals were in between, and you can speed this up too. So Nick will be doing get UID.
And so with setuid and setgid binaries, you have the ability to take the permissions of the executable that you're using. If you've ever been playing around with chmod and you see the mysterious first octet, it's like if you ever want to change permissions, you set like 0755 or 0644, but you always set 0 because you don't want to mess with that first octet. Setuid and setgid are going to be part of that. So setuid sets the process owner to the owner of that file. And similarly, setgid sets the process group to the group of that file. And generally, when you're dealing with this, it's because you want to take a executable and allow that to run as root, regardless of the user running it. Very popular to be seen in sudo. And so this can be useful to enumerate, particularly if you're on a box that has custom developed software. And so if you're looking for it, the find utility is fairly great if you've never used find. And so you just type in a path and then list the permissions, 4,000 for setuid binaries and 2,000 for setgid binaries. And this is like, it sounds trivial and like it's not going to be useful, but Your system now is only as secure as your root setuid and setgid binaries, which is a really, really big deal. If you've ever heard of GNU Screen, an alternative to TMUX terminal multiplexer, that was originally installed as of summer 2016, I think it was summer 2016, as a setuid binary root. And so an exploit via Screen allowed any local user to become root and completely attack, own the system, just because Screen was setuid. Fairly big deal. And similarly, if you've ever played some war games where you SSH into a system, generally you're going to see setuid binaries here. If you're traversing through the levels as different users, they allow you to grant user access in a manner that allows you to exploit users. Fairly neat. So as an example, if we hit, we scripted all of our stuff because that way we don't have to type it wrong. And so if we go look at setuid, maybe. Yeah. So the find script is just the previous script that you saw on the PowerPoint, but it'll give you an idea of what kind of binaries can be running as setuid. And most of these you probably haven't seen, but things like su or sudo are definitely going to be setuid because they're giving you root access. And then like passwd, you have to be root to change the passwords in users, and so that's going to be available there as well. It also should be mentioned, Screen is no longer setuid. It is now installed as setgid utemp, which is not a security problem. But if you're ever working on an old system that hasn't been updated, it's worth checking Screen, because if Screen is installed setuid, odds are you can exploit it. And that module is publicly available on ExploitDB. And so it's trivial to run. It's a shell script and really, really easy to get root with. So now we move into something that's significantly more granular, which is the Linux capability system. And that was added in kernel 2.2. So it's actually a fairly old feature, although not a lot of people have really discussed it, at least with my experience. And it switches the traditional privilege model of like a root user and a non-root user, or a super user and a non-super user, into more granular capabilities. And this follows into the line of the idea of least privileges. And so you're allowed to assign binaries only the things they need to continue executing, which is a fairly neat idea. Question, explain setuid and setgid again. All right. And so setuid allows you to, I'll show you all the files. That'll make a lot more sense. So I found all the setuid binaries here, as you can see. So if I check the permissions of these files, sudo for instance, you can see that it's readable by no one and writable by no one, but it is owned by root, and the group is root, and it has an S here in the execute slot. That means it's been setuid. If you check, depending upon how your color scheme is, a lot of time these binaries show up red, which is fairly handy to identify them quickly. But whenever you run a process or run a binary, it takes the user of it takes the user permissions of whoever's running it. And so here the username is CSG. And so if I were to run it, it would be running under the privileges of CSG. In the case of sudo, because it's setuid, it takes the privileges of the user root, which means that assuming sudo is written correctly, I can't do anything. But if I found an exploit in sudo, I can immediately become root because the process is root, regardless of who runs it. And so this makes permission significantly more difficult, because if you don't realize one of your employees wrote a setuid binary that's root, and it's terrible, and like you can break it really easily, everyone can get root on your system fairly trivially if they can break the binary.
So why might someone mistakenly make a setuid binary? Because it sounds like a terrible idea.
So let's say for some reason I wanted to write a wrapper that, as root, could set user, like I could modify privileges in the password file, so I could change users there. So I write this really neat script that allows you to do that, and so it edits the passwd file. I can add users at will. Really, really handy. Anyone can run it because it's setuid. It gives me the flexibility of not caring about permissions. The setuid binary can literally do anything at once, and that means me as the developer doesn't have to care. Until I write it poorly, and then you break it very easily, and that is that. It's similar. If you don't know about capabilities, there's a lot of things that you can't do if you're not root. Writing raw packets to a socket, you cannot do, which you may need to do. And so you, instead of setting a capability to do that like you should, you set UID because you don't know what capabilities are, and then it's very easy to break. And back to capabilities. And capabilities, similarly to set UID binaries, only affect the executable. And so they affect the running process after the executable. These are not user-level capabilities. But so looking at capabilities actively in use, ping is probably the one that was most apparent to me and maybe most apparent to y'all. If you've ever touched an older system or a system that doesn't have capabilities, you actually have to be root to ping. And so you try to ping, it will say your permission is denied, and you have to sudo ping something, which growing up post-1999 on computers, that seemed kind of dumb to me until the capability system makes a lot of sense. Because if you want access to a raw socket and write raw packets to the socket, you need to be root. And that's, of course, why ping has that capability. And so this is useful ways to manage capabilities. A handful of binaries available to you as a user or an administrator to interact with these. Getcap will list all of the capabilities available to you. Setcap will set the capabilities, and then capsh will list the capabilities available to the current process. So if for some reason you have a shell that you're trying to exploit because you're legally exploiting the system, capsh may be a handy way to enumerate what you can do. Because just because you're not root does not mean you can't do all the things root can do if you have all the right capabilities. And I'll demo that really quickly so y'all can get an idea. And so we have a very simple script. It just runs getcap tac-r. It operates recursively over a directory, making it really handy to list out various capabilities. And you can see the only one here is ping, which has the effective permission of capnet raw, as well as capnet admin. And there's a lot of capabilities. I think there's 38 right now. And so it can be very difficult to establish what is doing what. But that kind of stuff's easily Googleable and not really useful to know what all of them do immediately. There's some consequences of this, unfortunately. It seems like a really great process to make all these rules granular and allow only certain things to do certain things. But some people have claimed and demonstrated examples of how a large majority of the capabilities are more or less equivalent to root access. If you're interested in that, it's a post by one of the GR security guys. Their organization is in an interesting state right now. They used to develop a system similar to SE Linux or AppArmor. They quit developing that 2 summers ago. It's within the last couple of years. But one of their developers posted this link. I would recommend reading through it if you're interested in capabilities. It describes things like how the ability to mount a file system is equivalent to root because you can continue to backdoor things. Super interesting read, but kind of more in-depth on capabilities than we were looking to go. And on to file access control lists with Andrew again.
So file access control list seems kind of redundant if you use Chmod because it's basically, you think it does the same thing. And it does do the same thing at the end of the day. You get to change what user has what access to what directory and what they can do in that directory. But you can set a bit more specific permissions with set flac, if you want to say that, with set user file access control. So it just allows you to set a group and set a user and set what permissions they have for each file and each folder. And you can even change what file and folder that user has access to on the fly. You can set this with rules for people who even create users. So if you create a user and they created a part of a certain group, you can set that user to be a part of a certain group without having to chmod the folder or the file for them to access. So a couple of the commands are get FACL, and that's basically just, you can do this on a directory and it'll show you the permissions. So if I go over to this and I go and I just created a script for the set, but if I do get FACL and then I do the directory test, it basically is going to show me that the file or folder, which it's a folder in this case, is test, and it's owned by CSG and the group is CSG, and the user CSG has write access to it. If I want to change that, I can simply use the set command, and the set command allows me to modify the user's permissions over test. So basically, you're using the M tac to change the permissions of the user CSG to have write, read, or read, write, and execute permissions. So if we just run this, then and we do another get on test, we can see that now we have now this user CSG has write, read, and execute permissions compared to when it only had write permissions. So this is really helpful if you're doing something like running an SFTP server where multiple people are getting on and putting files. Instead of having to go in for every user and set them to be able to go into certain files, or setting a group and everyone going a part of that group, you have more control over what user does what. Whenever I ran an SFTP server, I used file access control so that whenever a user logged in or created an account, they would have a certain default path that they could go to and log in as. So Nick will be doing auditing. I believe that file access control overrides Unix, if that's your question. It sets the Unix base. It's just, I guess, an interface, really.
So
you can, if you're a user and you don't want to run sudo, and you want to set permissions on your file for another user to access, that's what you would use file access control list for, really. So you don't have to sudo to be able to change it.
So it overrides.
It overrides.
okay, but does it continue to display the old Unix permissions if you look with ls tech?
It shouldn't, but we can check.
I think it does.
It does?
Yeah. Oh, 5. So if we take his script and switch it to remove, actually we have other users we can add. So if we look, we have the permissions on that a group can read. And so if we chmod 0700 on test, you can see we now removed at the Unix level the permissions. And take that and make that group, specifically group CSG test. And so because it was the same group, it is changed. I'm not sure on other groups. So if we look on other groups, let's say the cockpit WS group. Or the Andrew group. Andrew group will work. And that also changed it. And so get fackle test, right? Fackle. And so as you can see, I guess at the group level, it must be as permissive as an underlying level, is what I would assume.
Yeah.
Is that what you've experienced?
That's what I've experienced when I used the SFTP, or whenever I did it with SFTP.
That's good. Okay. Yeah, I checked. And on to auditing. So if you've never dealt with a system that has had any sort of curious behavior or incident, auditing is a large part of remediating that problem. It's very difficult to figure out what someone has done if you're not actively logging it. So that's the purpose of auditing. So AuditD does this for Linux, and it provides more information should an incident occur. So you have a lot of logging either with journald or syslog or rsyslog, any of your logging mechanisms, but these are not necessarily directly designed for auditing. So audit D is. And it's really designed to allow administrators to quickly show what activity has been happening. So for me as an administrator, if I would like to audit syscalls or audit file system accesses, based off the rules I have set, I can quickly do that. Unfortunately, audit D is rule-based, and so your auditing is only going to be as good as the rules that you have set. And so you may be at a disadvantage if your rule list is very complicated or hard. But it's a very, very powerful framework, only being able to really check system calls and file system access, but it allows you to do a decent variety of things. And so it allows you to check any sort of file access, so read, write, or execute. It allows you to check system calls, so it actually plugs into the kernel and audits every system call and what user and process is executing them. You can check commands run by checking the execute status of a program. You can check failed logins with PAM, and you can check firewall changes through syscalls. A fairly neat system if you're looking to better protect it against malicious users. So Red Hat provides examples in their documentation that I think are fairly useful. And so you can change here. You can check files, as you can see here, what permissions are being used on them, so write or access. And then -k is going to be the rule name that you're setting. And so in this case, anyone who writes to etc password, which is the database for all users, it will be audited, and you can then go check it. Similarly for insmod, and so if you've never played with kernel modules, they are external code that you can compile and run in the kernel. Generally useful for device drivers, but there's other ways to use kernel modules. And so here you can check anytime someone executes insmod, you take that and audit it as a module insertion. Also really useful because modules can be particularly useful for backdoors, because if I can insert a malicious kernel module, I'm basically running at a level below root, and that's quite a bit of fun if you're trying to be malicious. And then as an example of system calls, if someone's trying to adjust the time of day, there's a bunch of interesting cases. If you're trying to DOS someone and allow them and break a lot of their crypto, you can set their time way back because a lot of things will fail. But an example of if you're trying to audit syscalls because you know certain ones shouldn't be called, it's available there. And now, like, setting rules is useful, but most of us don't really care at that level of granularity. So the actual useful things for us are AU search, which allows you to query audit logs for events. So if I'm confident that Andrew has been on my box and modifying things, I can just check all of the audit events for his user, which can be fairly useful. And then lastly, probably the most useful as a user is AU report. It'll take the default audit rules that are running and show you an example or a list of those events. So if we go into audit script, it's actually really easy. It's a single command. But we run AU report, and we have to be root, and type in our password. You can see we actually have quite a few events, even though we just set this up recently. You can see the time range is since I provisioned the box today until now. And as an aside, if you're using any RHEL-based system, Fedora, Red Hat, CentOS, audit D is going to be running by default. I can't say the same for Ubuntu. I don't actually know, and unlikely on Arch or Void Linux or anything else that is not running built with audit D enabled. Also should be mentioned, the audit subsystem of the kernel has to be compiled in, and so you're beholden to your maintainer of your distro. So Void Linux, for example, cannot use the audit subsystem because it's not compiled in, unfortunately. I'm not sure why this is. It could be a systemd-ism. It may not be. But if you're using Fedora, it's readily available to you. So you can see here, we've had 208 changes in configurations. We've added or modified accounts, groups, and roles 14 times. Probably the most useful thing as an end user is you can see that we've had one failed login. So someone attempted to log in this case, over SSH and failed. We've only had 7 logins. And then it just continues to go on. So we have the number of authentications. So if I'm using sudo, that's an authentication. Number of times we failed that, which is kind of high, which is kind of sad because we can't type. And so it just runs down. This can be really useful if someone is on your box actively doing things and you can keep track of who's doing what. if I have a rogue process that's just trying to log in over and over again or failing at authenticating, it's a pretty good, pretty easy way to identify that is through the audit system. And not mentioned here, but interesting if you like, the Elastic Stack. So we've mentioned it previously. It's Kibana is a dashboard for analyzing logs, and you can feed them in from a bunch of different what they call beats. They provide Audit Beat, which directly taps into the audit subsystem and streams all this data out to Kibana for you. And so if you're looking to get a visualization of your audits and not having to actually use AU report because it doesn't, it's not the prettiest interface, you can very quickly build dashboards with Kibana and Audit Beat. Fairly neat system. Yeah?
Does audit put all of the information it gets in syslog?
So it doesn't put it in syslog, but it does put it in a log file. You may be able to configure it to feed it into syslog, but if you don't want to use something like Audit Beat, you can also just tail the log files that Audit provides himself. Does Red Hat / Fedora come with a default rule set for Audit D? Yes, that is what we're running right here. It does some very basic things like logins, authentications, some system calls. Most of what an end user or an administrator would be configuring is things like actually watching etc passwd or actually watching a specific file you don't want people to execute. Or I guess I misspoke on that. Auditing is really not for catching people doing something you don't want them to do, but rather catching things that you may not want them to do. Adding a user is not inherently malicious, but if I audit that and I see that someone added 5 users and I don't know any of them, it's very easy to see they are being malicious with that. And securing services with Andrew.
So for the first service, we're going to be talking about SSHD, which is basically just SSH daemon. If you use, you can really, it doesn't matter whether you call it SSH or SSHD. When you do turn it on in the services, if you're using Ubuntu or any Debian instance that has SSH installed, typically you can use SSH to start it up, but when you're using Fedora, you have to type in SSHD. Basically, what SSHD is it allows you to write a config file, and it's the daemon for SSH. SSH also has a config file, but SSHD is the daemon for it, so you can stop the service and restart it. So the config file is located in etc ssh and sshd_config. For the options, these are a couple of the options that I use in my personal box and is relatively secure for just a default option. Permitting root login over SSH is not a good idea generally. You don't want someone to be able to just log in as root if they brute force your password, if they grab your key, or maybe there's an exploit or something like that. Public key authentication basically allows it so that if you create an SSH key and you add it to the public key section, which is can be located anywhere, then this makes it so that you can log in with that key. The authorized keys file is the file that you put your public key in so that you can be authorized to use. You can put this in anywhere, but typically people put it in .ssh. You do have to make sure the permissions are right, so you can chmod 700 or 644 for inside the file. And then password authentication. I don't use password authentication for my boxes because I have the key. But if you want to use password authentication because you think your password's strong enough, or you don't think too many people are going to be hitting your box or it's secure, you can turn this to yes. You can have public key authentication and password authentication enabled, so you can log in either or. But if you do disable both, you won't be able to log in to your box. So keep that in mind. Permit empty passwords just means that people can just hit enter constantly to log into your box if it's permitted. So you don't want people to be able to log into your box with an empty password. If you have an empty password by any means, maybe you install a service that's running that creates a user, and that user has an empty password that you just don't set, and they log in with SSH. So two things can be learned from that: is don't install services you don't know that might create a user, and also don't permit empty passwords. And then use PAM. Earlier, Nick talked about the different PAM rules, and basically this just enables them. You can disable them if you want. It's up to you really if you have a PAM configuration or if you don't want to use PAM. If I can quickly show you. Do we have access to SSH config on this?
Yeah.
Okay. So if I go to this is the location of the SSH config, SSHD config. So you can. So I can just. Let's do less. So basically, the beginning is what we have here is if I scroll down to the stuff that I was talking about. Authentication, we have root permitted. Don't have that. We just have that because this is not a box that we're using actively. Then public key authentication, again, we have it as we don't. If it's commented out, that means that it's disabled. So, but typically you'd want to have it yes. And then in the authorized key files, key file, you can actually instantiate multiple places that you can have an authorized key. So if you put .sh/authorized keys and you want to have another location for those keys, you can just put a space and then the second location for public keys to be accessed. If you want it to be in the directory of whatever user, you just put a tilde beforehand. And so if we scroll even more down, we can see that we start to see the password authentication and the permit empty password. We have password authentication, so we can log into our box with our password, and then empty password is no. It seems boring, but people typically forget to configure their SSHD config when they first get on a box, so it's one place that you might want to check whenever you're on a box. Oh, yeah. Okay, so for those of you who don't know what SSH is, it's this handy service that lets you go and have a shell in your box. Whether your default shell is bash or sh or zish, like it doesn't matter what the default, or Python 3 if you like that. If you use Emacs as your shell, that's wonderful. But basically, SSH just lets you have a connection to your box, and these are the settings to make sure that they're secure, and not everyone can just have a shell or a Emacs shell on your box. And for firewalls, so let's say you set up SSH and you're good to go in that department, and you have key-only login. Now you need to secure your firewall, or secure your box with a firewall. And by default, most, if not all, Linux boxes have iptables. And iptables is the underlining thing that most programs interface with whenever they are setting rules for your iptables. Now, iptable rules can be a little bit complicated or tricky to write if you've never written one before, or if you've never seen one before. So there are a lot of things that you can do to interface with it. iptables in general, the rule is you can block ports, open ports. You can put certain ports in groups, which means it has certain permissions. So let's say you want the entire IP range of a country to have access to only this port, and another country to have access to another port. Basically, that you can set that by setting different zones, and iptables is really good to do that. You can also just flat out block IPs and block ports, and you can open ports and deny ports. So one of the two main, anyway, interfaces that people use are Firewalld and UFW. If you're using a RHEL, Fedora, CentOS box, you will most likely have Firewalld, or as some people know it as just Firewall CMD. If you're using a Ubuntu or a Debian box, or you installed UFW because you like UFW, then you will have UFW. The difference between these is Firewalld more acts like an API. It basically just gets information from iptables and sends information to iptables. You're not really, it's not interfacing anything other than just sending commands to iptables in a really nice, pretty format. UFW, it has a full GUI if you install the GUI. If you just use the command line, it just makes everything simpler as far as whether you're using UFW or Firewalld. It just makes the output and input a lot prettier. Another thing is I would recognize is that if you have firewall-d, you have to reload every time you add a rule. Or if you add 3 rules, you need to reload at the end of that. UFW typically reloads on its own. Also, you can set it to not reload on its own. I think by default it does not reload on its own, but you can. Yes, you have a comment?
So you're saying that when you use firewall D to change the rules, you have to manually cause the firewall to reload the rules?
No, you have to do firewall D tac reload.
I don't.
If you had a permanent rule,
If
always pull immediately.
yeah.
Yeah, I always just said permanent and temporary. So.
Which is not by default what people. So, the general case is that you have to you should reload if you're setting a rule like that. Okay. Anyways, so if we go on to some commands, to start up firewall-d, systemctl enable firewall-d if you're using systemctl, and then to start the session, systemctl start firewall. That's just basic Linux starting commands. But whenever you want, if you want to actually see if the firewall-d is up, you can check the state of it. And then to the actual part why you would use firewall-d or firewall CMD is adding a rule. So basically, firewall CMD is just calling the command. Then you call the zone. So if you want this to be the public zone, which means it's out-facing, by default, the public zone is the out-facing zone. So you add that to the zone. You add the service. So let's say you want HTTPS because you're running a web service. You would say HTTPS or the port / the protocol. So for example, I could put 22/TCP or 444.3 or 80, and then you can do the protocol / the protocol. And then again, to reload the rules, it's firewall CMD tac reload. So if I quickly go to this box and I quit out of this, and I go back to our scripts that we have that likes to freeze. If I can simply cat the firewall-d start script, which basically just enables and starts. Don't run sudo in your scripts. I just don't want to type it. So if we type that, and we do nothing at all. So if I do status firewall-d, we can get that it is active and that it's running the dynamic firewall daemon. So if I want to check using the firewall command, I can simply do sudo firewall-d, or if I believe I have a script for that. So basically, it's going to be checking the state. So if I do, it's running. So it gives me a very condensed version of what the status was, which is nice if you don't want to read all of that, if you don't have an error. And then to add a rule, I have this script, which basically all it's doing is it's enabling SSH on the public port, and it's making it permanent. It's already enabled because I'm SSH to do it right now, but if I run it, then it'll just tell me it's already enabled, so I'm doing nothing at this point. So if I want to reload really quickly, I type in firewall cmd tac reload, which I don't need to because it's already enabled, but that's how you add a port add a port to firewall-d, which interfaces with iptables, which is your firewall on your box. So if I go back, I can start talking about UFW, which is very simple and it is on Ubuntu if you install Ubuntu by default. I can't test it because we have a Fedora box, so you're just going to have to trust me on these commands. But UFW status, it checks the status, whether it's running. It'll have similar output to firewall CMD state. Then allow port, UFW allow 22. Yes, very simple. You can just allow it's 3 words. Very simple. There is more complicated commands for UFW, but for the purposes of this tutorial or this like overview, this is a really basic way of allowing ports and IPs. So you can do the same thing with an IP address actually. So if you did UFW allow IP and then the IP address, it'll allow that IP address. Or if you want to deny an IP address, you can deny an IP address. Or if you want to deny a range of IP addresses, you can do UFW, deny from then the range of IP addresses that you want to deny. Another useful tip for UFW is that make sure the service is running, because it might not be. I've had that problem. And so if we continue, we will go into intrusion detection, which Nick will cover. Let me, yeah, let me scroll down and see.
That's the question.
Oh, that's the question? OK. So key-based login is basically where you have, it's like a key to a door. There's two parts of the key. There's the key and then there's the lock. In this case, the lock has to allow that key. So when you generate an SSH key, you're generating a lock and a key. And when you put the lock on the computer as the authorized key section, you can use your lock to unlock the door or unlock the port to get into the shell. That's a really, really basic way of explaining it, but I hope you understand. Sounds good? OK. Now let me. Sorry, headphone users.
And on to intrusion detection. A section surprisingly covered in the Red Hat security manual. At least I was surprised. Generally not something that you're going to be seeing in a standard deployment simply because of the perceived complexity that goes along with it. But in this case, it's actually very simple. And so some background knowledge that's useful to know to understand how the aid utility works. Linux is going to be primarily configured through flat text files. Almost everything on your system can be configured with a text file, which is, opinions aside, if you're a Linux fanboy, you probably like it, and it's really handy. And so, for example, users, every user on your system is an etc passwd. Every password on your system should be an etc shadow. It may be an etc passwd, and if it is, Google how to fix that real quick because it's not good. But passwords should be an etc shadow. And then, like previously discussed, all of your authentication configuration will likely be in etc pam.d. So, like, why is this useful? So, AID, the Advanced Intrusion Detection Environment, kind of snapshots the file system state based off what you describe it to take a snapshot of, and then compares it on subsequent runs. And this doesn't sound very useful. It sounds kind of trivial, actually. But it lets you do some very, very powerful things. And so if we look at my box where I have AID set up, we can take... Oh, I didn't write the AID scripts. That's OK. So the AID utility is fairly simple. You can start it with AID tac I, and you initialize the database. We can take a look at the AID config file. Conf. And they have a bunch of basic config at the top. Should be mentioned, these are not the default rules shipped with Fedora. They are actually a lot more complex. I made them a lot simpler, so it would run a lot more quickly. But it's very, very basic. All we do is check the integrity of etc passwd. And so in this case, we are going to check the last access time, the last change time, user permissions, as well as the contents of the file. So if we run AID in check mode, tac-c, you can see that there are no differences between the database and the file system. Good for us. That means no one has modified that file in any form or fashion. But as an administrator, I'm allowed to add users. So if I add a user named Alan, we can now check again. And you can see that we have a much longer output saying that we have 2 entries changed. And that's the etc passwd and the etc passwd- file. And so as a user, you can very quickly check and see that configuration has been modified on your system, and very cheaply in this case. That ran in a matter of less than a second. And so you can run this on a cron job, so run it every hour, and then check very quickly to see if your database has been modified. It sounds like that doesn't sound like a super big deal, but if anyone gets on your box and adds a user for any sort of persistence, like you can trivially check that. Like that's just a cron job you run every hour and send an email on a failure. And you have host intrusion detection system, like trivially, super, super handy. And just for sake of like completeness, you can update the database with aid tag u if you're root. And it runs again. It dumps the file into a new database. You copy the database over to the expected location, and you're good to go. You can even, like if you're feeling really paranoid, you can take these outputs of the hashes of the database, and then you can store those elsewhere. And so if you're on a system and you think it's been attacked, you can check and make sure the hash matches. Super useful for you as an end user, because assuming someone is attacking your box and they know you have aid deployed, it would not be hard for them to change the database and you would never know about it. But as long as you can check the hashes, they really cannot change it. Like cryptographically, they can't change the database and you not know about it unless they find a hash collision, or it'd probably actually be a pre-image attack. Very difficult hash attack that you would have to be able to do to attack your box. Not likely going to happen. Yes, just don't pick MD5. As an aside, MD5 is super vulnerable. SHA-1 is vulnerable to a collision attack. MD160, no idea. SHA-256 and SHA-512, generally considered secure today. I would recommend taking those if you're looking. Does aid provide any real-time monitoring? And how do these checks differ from audit dechecking? So aid is designed to provide non-granular alerts on large changes. It didn't tell you what entry changed in the database. It just told you that the file changed. So you as a user are using this for alerting, not auditing. Very similar but different concepts. Auditing is going to be used, you know that you've been attacked and you want to find out what they did. Alerting is, I'm being actively attacked recently and I want to stop it now. And so it doesn't provide real-time monitoring, but it's designed in a way that you run it on a cron job, which means you run it every periodic time period. This could be every 5 minutes, this could be every hour, this could be every day, based on your needs. And then you can even have your cron tab set up to send you an email if any of the cron jobs fail. And so you could very trivially set up aid in check mode. It runs the check every night, and you can see within the day if someone's added a user. Depending upon the number of files you're checking, if you're doing only very small number of files, like the past ABD file, you could run that every 5 minutes. And like you don't care because it's so cheap, and you can tell within 5 minutes someone's added a user on your box, which could be you, but it may not be. What does aid databases contain? Depends upon how you configure it. You can have it be very granular. You can have it be very verbose. And by default, it's going to check file permissions, I think owner and group, and the content as well. It's largely information that's found in the inode. It's mapping that to the database. But that's all fairly configurable. If you don't want all that data, you may not. And so you just may not care. And if you're like looking for more, aid is super well documented online. It's fairly verbose in features. And so if you're really looking to configure this on your system, I'd highly recommend reading the documentation yourself, not just deploying the basic config I just showed. Oh, rough. We were doing so good without crashing the questions. Oh. And that's that. So new questions once again. Oh, continue recent. Oh, can we continue? Let's go. We can continue. Awesome. And so now on to compliance. If you're dealing with any sort of system at any sort of business that has to touch any sort of private customer data or payment card information, any sort of medical information, probably if you're dealing with FERPA information, anything that's legally required to, another question. How does this compare to running, oh, it moved. There we go. How does it compare to running an IDS on pfSense, for instance? So this is not 100% across the board, but generally if you're running an IDS on pfSense, you're going to be running Snort or Suricata, and in which case those are doing an IDS in the network sense. And so they're inspecting your network traffic and trying to identify malicious behavior there. aid as an IDS is only checking file system changes. And so it does one thing and does it well, but it is not going to check if anyone's nmapping you. Aid will never alert with an nmap. I wouldn't think. You might be able to do it, but probably not. It's not how it's designed. An IDS on pfSense likely going to be ingesting network traffic and checking for malicious behavior, whether that be Metasploit or Meterpreter or anything like that. Oh, why do both Etsy Shadow and Etsy PassWD exist? Back in the day, Etsy PassWD had both, but it needs to be readable by a lot of the system. You're actually globally readable with Etsy PassWD. And so they moved Shadow to a restricted file that can only be read by root. And that provides some security there, and it also that contains your passwords in it, which is why, or password hashes, I should say, your hashed passwords. And so there's both, because I need to be able to check what users are on the system for a lot of things unauthenticated, but I likely don't need your password unless I'm a root program. And I think that's all the questions. Yeah. And I hit escape again. My bad. We're only on the last slides, so if you have a question, just raise your hand, because I don't want to deal with setting it back up, because we're almost done and we're running late on time. So if you're any sort of system that has any sort of user information that needs to be protected by a legal standpoint, you're likely going to deal with compliance. It's also possible that another corporation provides, like your upstream corporation provides compliance standards for you to hit. And so in some form or fashion, if you're dealing with infrastructure at a corporation, probably will touch compliance. Fortunately, there is a standardized way to do that. You have SCAP, the Security Content Automation Protocol. I have not found a comparable into Windows, but that could just be my lack of knowledge. But it's developed by NIST, and it allows automated configuration for a secure environment, which is actually really neat. And so Linux, OpenSCAP is the utility that does all of that. And if you're on a Fedora system or a CentOS or Red Hat system, I would check out SCAP Workbench. It's a GUI tool that lets you do all of your compliance. OpenSCAP is the OSCAP is the command line variant of that. An idea of how OpenSCAP works: you have the SCAP security guide, which is a baseline security compliance that they think all systems should follow, very, very close to the Red Hat security manual. You have SCAP Workbench, which allows you to scan and check yourself against these compliance standards. SCAP to me, which is a centralized database for your compliance system, fairly neat. And then OSCAP Anaconda, which Anaconda is the system that builds Fedora-derived systems. And so if you want to build a compliant OS, do it really quickly with the Anaconda add-on. And a quick demo. We have, and I'm going to fail, because not everything they recommend in their default guide is useful. But you have an idea. We specify the common profile, and we use the Fedora set of tooling or rules, and we run it, and it just starts kicking through everything. It checks and see, like, oh, are we verifying signatures on our package repositories? Yes, we are. Do we have an aid database? Something about the way I configured it, they don't like that. They do not like that. Are the RPM file permissions correct? Apparently not. And so you can run this long scan. And SCAP has the really nice feature that you can then generate a remediation report. And so you can take all of these, and you can see what you're failing on, and then just tell OpenSCAP to fix it for you. This may be a bad thing if you're like customize things like, oh, I need it this way for a reason. But if you're just trying to get a baseline security and you're comfortable with the results, you can just have it fix it for you automatically, which is fairly handy. Yeah. Probably. I have not delved that deep in. I normally just check what is wrong and just say, go ahead, fix that, because it does a fairly good job. It should also be mentioned, you can write your own SCAP guidelines if you wanted. So if you administrated a lab of some sort with very specific policies and compliance standards, you could write a SCAP policy that then gets automatically deployed. Fairly neat. And that is it. A lot of material: authentication, authorization, audit, services, firewall, intrusion detection, and compliance. Not everything you need to know for Linux security, but certainly a good start and a good jumping off point for learning more. We did not hit SE Linux or AppArmor, which is a shame, but it's already 8:15, so I don't really feel bad about that. if you're really interested in Linux security, SELinux and AppArmor are super neat utilities that do really cool things, but they're also probably more complex than anything we talked about tonight. And so if you want to spend your time and learn them, great, super cool. Definitely a place to continue reading if you're interested. Other than that, that is it. Get in touch with us, like previously said, and thank you all for coming.